Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, on to day 2 for lesson 4.3.2, distributive property. In this lesson now, this part of the lesson, we are going to get more deep into what's going on when we use distributive property. Okay, so it says parentheses in an algebraic expression allow you to show that tiles are grouped together. So it says build these steps with algebra tiles. Use an X tile to represent any number. Okay, so once again, you don't have access to the tiles in the classroom, but you do have access to the online book, which allows you to use a tool to do this very thing. So let me go ahead and pull that up for a second. Okay, so you can follow along with me. I'm going to do this over here on this next page, or you could do this on your own if you were to pull up the online book, go to problem number 89, use the student e-tool. You click on this, and here are the directions here. So it's just a matter of, let me get that out of the way, of pulling these guys over. So it says think of any number. So your number is going to be a variable, right? So we would start with the x. And then if you triple it, then you need to make 3 times as many of those, right? So you're going to triple it 1, 2, 3, right? So 1 became 3, that's tripling it. Now you're going to add 1. Where's a 1? Where are you, 1? There you are. Now you're going to add 1, and then it says multiply times 2, okay? So you can go ahead and manipulate this any way you want. I'm going to go ahead and do the same thing here, okay? So we're thinking of any number, right? And that number is an unknown, so we're going to represent that with the variable x. So when you triple that x, now you got 3 x's instead of 1 x, correct? How do I want to do this? Maybe I'll put it like that. Okay. And then it says add 1. So now I'm going to add 1 to that. And then it says multiply times 2. That's interesting. What are we supposed to multiply times 2? Or are we supposed to multiply the 3 x's times 2? Or the 1 times 2? Or both? And the answer is everything gets doubled. So not only 3 x's, but the 1 gets multiplied times 2. So this becomes 2 times 3x plus 1. So if I double that, I'm going to double everything. So I'm going to double the 3 x's to make 6 x's, and I'm going to double the 1 to make 2. So after going through this entire process, our final answer ends up being 6x plus 2. That is essentially what's happening when you do the distributive property. You're going to multiply whatever your multiplier is, has to apply to everything that's inside the parentheses. And so that's why I tell students, send in these dive bombers, okay? Send these guys in, draw the arrows in, because otherwise you're going to forget. You're going to do 6 x's, but then you're going to forget to also multiply the 2 times the 1, and you're just going to write it as 6x plus 1. So this idea of making sure, and for those of you that haven't heard my World War II story about the American Navy fighting the Japanese out in the Pacific Ocean, the whole story about sending in the dive bombers is kind of lost on you, but just go with it, okay? So just think of this guy has to hit both of those targets, right? The first one is the 3x, the second one is the 1, so this becomes 6x plus 2, and that is what's happening with distributive property. So, all right, so it says build the following expressions with algebra tiles. Once again, feel free to do that with the online tool and rewrite the expression in a different way. So it doesn't say simplify the expression, it's just rewriting it in a different way, because if we don't know what x is equal to, we cannot evaluate or simplify these expressions. All we can do is use distributive property. And you're going to learn on parts B and C that distributive property actually goes in both ways. You can either send in the dive bombers to multiply, or you can find a common factor to factor out. Okay, so let's start with 4 times 2x plus 3. I started by building the expression that's inside the parentheses. We've got 2 x's plus 3 1s. And now this is saying, let's have 4 of those, okay? So do we want 4 of the 2 x's or 4 of the 3's? We want 4 of both. So 2x plus 3 once, twice, 3 times, 4 times. So this here is the final answer to 4 times 2x plus 3. Well, how many total x's are there? There's a total of 8 x's. And how many 3's are there? Well, there's 4 3's, which means that there are 12 1's. So 4 times 2x plus 3 is equal to 8 x's plus 12 because it's 4 times 2 x's and 4 times 3. Now let's see if we could work this in the other direction. This process is actually referred to as factoring because you are looking for a common factor, just like we would have when we were simplifying fractions. So if we took a fraction that said 12 over 18, and you were looking to divide this by the greatest common factor, you could divide it by 2, right? But you could also divide both of those numbers by 3. 4 doesn't go into the 18, 6 does. So if we were to divide this by 6 over 6, that would be the greatest common factor and reduce that fraction to 2 over 3. Well, it's the same idea here, okay? So let me show you what is happening when we divide by common factors. If I just leave it how it is 12 x's plus 18. If I decide to cut these 12 x's in half, and this would have to be cut in half as well. So we've got 6 here, plus another 3, 1, 2, 3, and then we're going to take those 3 and move them down here. So I could rewrite this. Let me go ahead and erase this over here so I can use that space. I could rewrite this as 2 times 6x plus 9, right? Since 2 times 6x is 12x and 2 times 9 is 18. But is that the greatest number of equal groupings that I can break this into? 3 goes into both of those as well. So if I broke these 12 x's into 3 equal parts, then I would have 4 x's in each part. And then I would break 18 into 3 equal parts. And we would end up with a total of 6 in each one of those parts. So we could write this as 3 times 4x plus 6. But can we break it up into more equal parts than that? And 4, no, you can't break 18 into 4 equal parts, nor can you break either of them into 5 equal parts, but you can break them into 6 equal parts. So what would you get there if we broke this into 6 equal parts? Looks like we would have 2 x's in each part. And so I'll break this into 6 equal parts as well. Bring these guys over here, bring this guy over there, and then this guy up, and there you go. In every one of those 6 parts, you've got 2 x's plus 3. So this is called factoring, and it's the opposite of distributive property. And you can tell if you've done it correctly, because if you just go and use distributive property, what's 2 times 6x plus 9? It's equal 12x plus 18. What is 3 times 4x plus 6? That is equal to 12x plus 18. And if you take 6 times 2x plus 3, you got 6 times 2x is 12x, and 6 times 3 is 18. So all of them end up being equal to 12x plus 18. So that's your check. Now, do you always have to fully factor? I guess not really. You just need to rewrite it. I mean, there might be a time where if you want to take this problem, 12x plus 18, and divide it by 3, then you'd want to rewrite this as 3 times 4x plus 6. And then when you divide it by 3, you can cancel out the 3 on the top and the 3 on the bottom, and your answer ends up being 4x plus 6. So that's the direction we're going with this. In high school algebra, you'll be asked to simplify some more complex types of algebraic expressions. And so having an understanding of how to factor is going to make that doable, okay? Right now, you're just being introduced to this idea, so it's not expected that you're going to be able to solve a problem like this anytime soon. Oh, stop it. All right, so let's do the same thing here. Go ahead and you can manipulate with the online tool, or you can draw pictures if you want to. just take a look at this expression and try and figure out how many total groups, what's the greatest number of groups you can get where you can break those guys into equal parts for each group. Go ahead and see what you can figure out there. I'll pause. All right, so I'm going to do the same thing I did before. I'm looking to see what 10 and 15 have in common. Honestly, I don't know really anything other than, let's see, this is 2 times 5 and 1 times 10. That's 3 times 5 and 1 times 15. It looks like we have 5 in common, right? So if we broke this into 5 equal groups, then it looks like we got 2 and 3 x's, right? 2 and 3 x's for each one of these. So I can grab a bunch of them. There we go. Yes. So this ends up being 10 divided by 5 is 2, and 15 divided by 5 is 3, so that becomes 3 x's. Now let's send in the dive bombers and make sure, is 5 times 2 equal to 10? Yes, it is. Is 5 times 3x equal to 15x? Yes, it is. So this would be the other way to write this expression after factoring. Okay, so distributive property can go in the multiplication direction, or it can go in the division direction, but that's what we would refer to as factoring. So your last task is to write an equivalent expression for 21x plus 3. No, plus 7. So if you want to use algebra tiles, you can do that, or you could draw pictures if you want to, or you could just kind of use a little bit of logic. See if you can figure out what this would be if we were to factor this particular expression into its most factored form. And I think there's only one other way of writing it, if I'm not mistaken. All right, so go ahead and take a little bit of time to look for the greatest common factor of those two numbers and pull that out. And then when you're ready, unpause, and we will figure out what the answer is. All right, let's see how you did. Well, I'm looking at 21, and that is 3 times 7, correct? There's nothing else you can multiply to get 21 except for 1 times 21. 7 is only 1 times 7. So we're not going to bother factoring out a 1. That, you know, you're going to get the same answer, right? Nobody's going to look at this and say, oh, that's factored. No, you don't factor out a 1. So the only other number you could factor out is a 7, right? Because those are the only two factors of 7. So if you pulled out a 7, what would you multiply times 7 to give you 21? That would be 3, so that becomes 3x. And what do you multiply times 7 to give you 7? That would be 1. So 7 times 3x is 21x? Yes. 7 times 1 is 7? Yes, it is. So this would be the other way to write that expression. This would be your factored form. And this would just be the original. And if you started with a factored form and you wanted to go to the original, you would send in the dive bombers and use distributive property. Okay? So, basic idea for distributive property. This is a property where it shows that when you are multiplying a number, this is the multiplier being multiplied times a sum or difference inside parentheses, then you would multiply this number times each one of the terms in that sum or difference. Okay? So, once again, sending in the dive bombers. Make sure that this guy hits each one of those terms and you multiply them together. That's distributive property. All right? All right. Less than 15 minutes for day 2. Hooray. All right, let's move on to the next activity. Okay, bye.
Hey, feeling good, like I should.